Okay, factorising polynomials. Example 1. Show that x plus 5 is a factor of this, and then factorise it fully. Now we're going to look at something called synthetic division. If you want to know that something's a factor, we need to show the remainder 0. Now we can put it indirectly, but synthetic division really helps with this. So how synthetic division sets up is you set up a little table, and the coefficients of the polynomial go on the top, but it has to go in order cubed squared. So if there's no squared, you put a 0. So I've got 1x cubed, 9x squared, 23x and 15. And we're showing that x plus 5 is a factor, so we're subbing in minus 5. So this is how this works. I'll use a different colour pen for this. The first step, the 1 just drops down, and then we times minus 1 by 5 to get minus 5. And then we add. 9 minus 5 is 4. And then we times. 4 times minus 5 is minus 20. And then we add. 23 minus 20 is 3. Then we times. 3 times 5 is minus 15. And then we add and we get 0. So we can then say since f of minus 5 equals 0, x plus 5 is a factor. That's all you need to write. Or since the remainder is 0, x plus 5 is a factor is another thing you can write. Good thing about this method, which is called synthetic division or the table method, is that it leaves you with a new polynomial. So you can then just say that you've got x squared plus 4x plus 3. Powers went down by 1, started with a cube. And that's going to be times by the factor that we just started with, x plus 5. So we can now factorise it because we've now got a quadratic. So we get x plus 5, double brackets, hopefully, x and x, 3 and 1, plus 3 plus 1, and we're done there. Factorising example 2, factorise fully this cubic. Now, the problem with a cubic is we need to know one factor first, or a root. And the easiest way to do that is just to sub in numbers until we get an answer of 0, because that means that you've found a root and you've found a factor. So you just trial and error here. You start with 1, then minus 1, 2, then minus 2, 3, then minus 3, and so on. I'll do a few for you. So when x equals 1, we get 2 times 1 cubed plus 5 times 1 squared minus 28 times 1 minus 15. But that equals minus 35. So x equals 1 is not a root. So we try x equals minus 1, and you get 2 times minus 1 cubed plus 5 times minus 1 squared minus 28 times minus 1 minus 15, and that would give you an answer of minus 8, just 18. So that's not a root either. And eventually you try 2 and minus 2. And usually a higher maths, you'll not have to go past 3, right? Unless it's going to be nasty. So don't worry, if you're not getting the answer, just keep going until you get 0. So I'm going to keep going, and eventually I'll try 3. When I try 3, I'll get 2 times 3 cubed plus 5 times 3 squared minus 28 times 3 minus 15. Now let's actually do that sum this time. 3 3s are 9 times 3 is 27 times 2 is 54. 3 squared is 9 times 5 is 45. 3 times 28 is 3 30s is 90, 3 2s is 6, it's 84. So it's minus 84 and minus 15. 54 and 45, well that's going to be 94, 99. So that's 99. 84 and 15 is also 99, so that equals 0. Therefore, x equals 3 is a root. So x minus 3 is a factor, remember. Just a note, I find subbing in directly the quickest way, but you can use synthetic division when you're subbing in as well. And you're going to have to do that anyway once you've found one. So I found x equals 3 is a root, so I put 3 in, it's a root you put in, remember. And the polynomial was 2x cubed, 5x squared, minus 28 minus 15. Minus 28x minus 15. So we're going to end up doing this. We know we're going to get 0 in this last position. So this is a double check for us. So we take the 2 down. 2 times 3 is 6. 6 plus 5 is 11. 3 11s is 33. 33 minus 28 is 5. 5 3s is 15. 15 minus 15 is 0. And therefore we've got x minus 3, remember. And then we've also got 2x squared plus 11x plus 5. So that's has now got it down to there. And then we need to try and factorise this bit. Now, sometimes this will be factorisable and sometimes it won't. One quick way to check if it's factorisable is you do the discriminant. But let's just double check anyway. We've got x minus 3. I know this is factorisable. you get 2x and x in the first position. And two numbers at times together make 5 is 5 and 1. So 2 5s is 10 plus 1 is 11. So it's just 5 here and 1 here, plus and plus, and we're fully factorised. So finding roots. Example, given that f of x is x cubed minus 37x plus 84, show that x equals minus 7 is a root, and therefore solve f of x equals 0. So for solving it, it just means we're solving the equation that we end up with. Now, you could sub minus 7 indirectly, but I find that the only reason to ever sub indirectly is to find a root initially, a small one like 1, 2, or 3, or if there's two unknowns, and then it's easier to sub indirectly than it is to use the synthetic division. Otherwise, I'm going to always use synthetic division because it's just much quicker. So I do my setup synthetic division. Minus 7 is what I'm subbing in. We've got 1x cubed. Now, careful here, we've got no x squared, so I write 0, then minus 37x plus 84. So you need that 0 because there's no x squareds. Take the 1 down. 1 times minus 7 is minus 7. Add them to get minus 7. 7 7s is 49. 49 take away 37 is 12, I think. And then 7 12s is 84, but it's minus 84. And add them to 0. So I can just say that since f of minus 7 equals 0, x plus 7 is a factor. Or you could say that since the remainder is 0, x plus 7 is a factor. That's fine as well. Now we can just go ahead and factorise this. X plus 7 times x squared minus 7x plus 12. But we have to solve that equal to 0. So we'll just say equals 0. And then it's just hopefully we can factorise. So we've got x plus 7, double brackets, x and x. 3 and 4 make 12, but add to make 7, so it's 3 and 4, 4 and 3, whatever. So minus 4 minus 3. So then we can just say x equals minus 7 for the first one, x equals 3, and x equals 4. And we're done there.